Hello again, this is homework number 1B for COMSOL Multiphysics. In this video I'm going to be showing you how to solve for flow between parallel plates. This is a kind of common problem. There's going to be two plates, one on the top and one on the bottom. There's going to be a pressure inlet and a pressure outlet, and the pressure inlet on the left hand side will be a higher pressure than the pressure outlet. Okay, so to begin, this is going to be a 2D problem. So I go and after creating a new model, I go and select 2D, click on the next button. This is going to be a laminar flow problem. So I'm going to click on fluid flow, single phase flow, then laminar flow, and then click on the next button. And this is going to be not a time dependent problem, but a stationary problem. So the values of velocity are going to remain constant over time. And then I'm going to click Finish. After I click Finish, I have the geometry here, the materials, laminar flow, and the mesh, all things that we need to work on for this problem. So the first thing I'm going to do is to define the geometry. In order to do this, I'm going to right-click on Geometry and choose Rectangle. That rectangle is going to describe the area where the flow is taking place. So again, I'm not modeling the plates themselves, I'm modeling the space between the plates. The width of this problem is going to be 50 centimeters, so it's 50 e to the minus 2 meters, and the height or the distance between the two plates is 10 centimeters, so that's 10 e to the minus 2 meters. I'm going to place this rectangle with its x and y coordinates bottom corner at 0, but I could change that if I want to do the center, or I could move this anywhere, and I could also rotate it if I wanted to. So I'm going to go ahead and build this object, and the object is shown here. Now I need to define the material. The material here is going to be water, and the way I'm going to do this is I'm going to right click and then open Material Browser and find the material that I want to use. This is going to be under Liquids and Gases, then under Liquids, and then I'm going to find water here, and then I'm going to add that to my model by clicking the plus sign here and then going to add material model. So now I have water, and it has all the properties. I could double check that the properties are correct, but I'm going to assume that they're okay. So I've settled my geometry, have my materials, and now I have to set up the problem. Okay, so on the walls, okay, we have walls 1, 2, 3, and 4. 1 is an inlet, 4 is an outlet, and 2 and 3 are the side walls. 2 and 3 make sense that the boundary conditions are going to be no-slip boundary conditions, but the 1 and 4 are going to be inlets and outlets. They're going to have pressures, so I need to essentially override these values. So the way I'm going to do that is right-click on laminar flow, and then I'm going to choose my outlet, or I'm sorry, my inlet, click on 1, then add this to my model. That's number 1. Then I'm going to set this boundary condition as a pressure boundary condition, and I'm going to have that be a 1 Pascal inlet pressure. I need to do the same thing for the exit, so I'm going to go back to laminar flow. I'm going to find my outlet, and I'm going to select the outlet as number 4. I'm going to add that to my model, shown here, and then that pressure is going to be 0. So the pressure on the inlet is 1 Pascal, outlet is 0 pascals, and the boundary conditions on the top and bottom walls are going to be no slip. I can then go to mesh, okay, and I can choose my normal predefined mesh and build that. Okay, so now I can go to my study and I can simply click the equal sign and solve this problem. Okay, so what you see with this problem is that we have a high velocity in the middle. It's 0.07 meters per second. You can see that the surface velocity is what's shown here, and at the walls we have very low, or 0 meters per second, as we thought it should be. We do have sort of strange things happening here. You can see these kind of lines here, and this is because the mesh itself is not a very fine mesh. So what I'd like to do is just show you how to change that. We can change this. You can see the mesh now. You can see where maybe those lines occurred. What we can do is go to a custom mesh, And right now the mesh maximum element size is 0.0335 meters, and that's basically a characteristic dimension of the mesh. So what we can do is we can change that, let's say to 0.01, something a little bit smaller, and click the equal sign. And as I mentioned in a previous video, for some reason it doesn't show you the mesh right away, but it's there. So we can go back to study, click the equal sign, and just wait a little bit. And now you can see that now that we have a finer mesh, we don't see these kind of strange things happening at the inlet and outlet. And there's a slight inlet condition here. So our results are shown here, and we have our 2D plot group. Okay, and the 2D plot group is what's called a surface plot, meaning that it's showing what the values of the velocity are on the surface of the model. We could have other types of plots. For example, we can add another 2D plot group that's going to be down here, okay? And we can right click on that one, and we can have that, let's say, be an arrow plot, okay? And click on the arrow plot, click on plot, and then we get some arrows here, okay? So our surface plot is shown here, and the arrow plot is shown here. And we can do a number of different things like that. We can also change our surface plot. Instead of velocity, we can put pressure here. I can show you how to find these later, and these are going to be in pascals, and we can go ahead and plot that, and now we have our pressure. You can see our pressure is high, but it immediately equilibrates, or we have basically a linear pressure gradient, but at the entrance we have some entrance effects. So this is where I'll end this model right now. As I mentioned, you can go around and play with the different plot styles. The important thing is going to be able to get meaningful data out of this model, and I'll show you that in a future video. Enjoy.